Awesome, I think this is it. All right, hello everyone. So welcome to our talk. Today we're going to be talking a little bit about our narrative system that we implemented into our mixed reality game Shattered. I guess, yeah, just a little disclaimer. I know this is a audio track talk, but we're actually covering a few different disciplines today. But yeah, so it'll be a bit all-rounder. So a little bit about Shattered. So Shattered is a mixed reality game developed by our PlaySide studio, specifically for the Meta Quest 3, utilising some of the Quest 3's pass-through technology to enhance some gameplay elements. So as you can see on this little clip here. So we actually map the player's room and we superimpose virtual objects onto the walls, ceilings, and floors. And the ones on the walls, have a thing that we call what do we call it again? Extensions, sorry. And we can have gameplay elements happening through the player's walls, which is very awesome. It's primarily a narrative experience where the players must solve escape room type puzzles in order to uncover the mysteries of the Greyvale Wellness Centre.
So in the development of Shattered, we needed to handle many kinds of recorded audio and dialogue with lip sync animations with many different characters in the scene. So today we're going to talk a little bit about the process and the tools that we developed in order to make that whole narrative development process easier for our team. A little bit of a disclaimer beforehand, or I guess a reverse disclaimer. This is a psychological thriller game, if you're familiar with it, but we'll be avoiding any of those sort of nasty topics throughout this talk. So a little bit about who we are. If you don't know me, I'm Benjamin Finlay. I'm a software engineer at PlaySide. I've been there for about 3 to 4 years now, and I've been in games for about 6 years. I'm a general lover of Minecraft, and I actually recently broke my leg bouldering. You could say it shattered into pieces, which is yeah.
Yeah, we appreciate your dedication to the game. Yeah, really going the extra mile. So my name is Zach. I'm a senior audio designer at PlaySide Studios. Been at PlaySide for about 5 years now. Had a live music background before getting into video games, but since being in the video game industry, I've gotten a bit of a love for the more technical side of audio. I've worked on some titles like Age of Darkness, Warcraft 3 Reforged. Ben and I worked on Shiba, Civ 7 VR, and Shattered. Shattered, of which is nominated for a few AGDA awards tonight, so let's go. Excellent. All right, so how did we make a narrative system? No, please, actually tell me. So today we're going to be talking about our proprietary narrative and organization implementation tool, which we internally call the Q library. So before we dive into the building of this cool tool, we actually had to do a bit of research onto what we needed the tool to actually do. So we needed to understand the team's needs, the team's problems, and do a bit of an R&D process.
Cool. So what did that process actually look like? And why do we actually get into it in the first place? So a bit of backstory. We had some initial milestones where a poor engineer, myself, was given the task of implementing all of the lip sync and dialogue and VO very manually into our build. And that was a very long and tedious process, which I'm sure some of you have been through, which is not fun. So that raised the point of, well, how can we make that better? And to do that, we wanted to get the rest of the team involved. So we wanted to talk about what those teams needed, and we ran around and asked them all. So our narrative team, they wanted to make sure they could write an external format. They didn't want to have to get an engine at all. They wanted the ability to quickly import that dialogue, so they didn't have crazy turnaround times. Our design team, they wanted to make sure that they could really iterate quickly, so they wanted to be able to hear it quick. They wanted to be able to immediately get voice lines in there, so we looked towards text-to-speech. And they wanted to make sure that was all really easy to call throughout their gameplay logic setup. Our lovely UI and UX team, they just wanted to make sure we had some localized subtitles in there. They didn't really mind too much. and our audio and animation team. They just wanted to make sure everything could really play in sync and was playing correctly.
Yeah, part of this R&D process was very much checking to see if this tool already existed. I mean, you've heard the expression reinventing the wheel, but we actually needed to make it do a few other things. So during this, research period, we weighed up a few other third-party options. So some programs like Artisy, Backlight, Yarn Spinner. Some of these may sound familiar to you. That slide's done a bit of a funky there. So we looked at the pros and the cons of what these systems were able to do, what these third-party tools were able to do. So some of the great things that they were able to offer was like a great user interface. So like narrative writers could work directly into these tools. There was text-to-speech elements. There was a completely separate user interface from the game tool, which is an added bonus for narrative writers. It quickly became pretty apparent that some of the things that we needed for our proprietary tech and the brand new systems that were the Quest 3, that we needed to extend the functionality of a lot of these in order to make it work well for our game. On top of that, it also costing like a fair bit of money to do so. So we would need some custom tech, and we would need to expand these tools out to be able to work well with our games. So we thought, okay, all right, if we're going to have to make a lot of custom tech, on top of these third-party solutions, what would be the likelihood of just building our own tool and make it completely purpose built for our games. Cool. Excellent. So now that we've sort of determined the team needs and what I guess the market already had to offer with some of these tools, we then needed to sort of answer some questions. We needed to make sure our tool, our version of this tool, covered a few key pillars. How would everybody use this tool? So the user interface, elements of it, how people would manually work with this tool, how can we handle quick iteration. So part of the reason that we needed to build a tool like this is because when you're getting down to the back end of development, you need to be able to quickly import voiceover. You need to quickly be able to update script lines. You need to be able to. There's a lot of things you need to be able to do in bulk. And when I say in bulk, it can be anywhere from like 1,000 to 20,000 lines that you need to be able to do at the touch of a button. So that was super important. Keeping everything in sync. So because this system that we needed to build essentially needed to handle animation, VO, voiceover, localization, and subtitles and things of that nature. And we needed to make sure that they were all locked in sync. And then also, this very, VR specific question, how do we position VO or voiceover in a VR, or MR world, mixed reality? If we can tick all of these boxes, answer all these questions, then we would have done our job right. All right, so let's start with the first one. How will everyone actually use this tool? Behold, this is the Q library. This is our proprietary PlaySide tool. So essentially, what this is, it's a database which in the back end also handles a lot of the triggering and management and source of truth for all of our dialogue in the game. It's like, cool, Zach, thanks for showing me a nice UI screen. This means nothing. So if I were just going to go through this a little bit in a bit more detail. So it's broken up primarily into 4 sections. So this part here is the queue window. So this is where developers can see the queue and line IDs. You're able to see sort of the status with those green green mark isn't on the side there. See if it's, if it's got still text-to-speech enabled, or if it's got its, complete actor files in there. We've got the search bar. Any good user utility will have a good search functionality. So this is obviously really good for categorizing specific levels, specific characters, what the file status is. So I want to check if it's only got, if it's got text-to-speech still active, or if it's, if I'm, my localization status is not quite up to date. I can filter that through here. The queue detail. So this is when you sort of highlight one of the queue selections there. It'll tell you a bit more detail about that specific line. So yeah, again, localization status, line ID, where it appears in each level, its text-to-speech status, the character who says it, all of that sort of data. And then this little window is the, I guess, bulk importing and bulk functionality tool. My notes. Yeah, so this allows us to import scripts very quickly. So I'll go through that a little bit more in a second. We're able to bulk generate our text-to-speech files through the touch of a button. Convert audio to the Wwise file format, just basically a file format that Wwise can read directly. And you're also able to delete bulk files from the back end just to clean it up before it goes to build. Awesome. So yeah, moving forward a little bit, let's just say we magically built this really quickly, and yeah, we'll move on to the how do we actually use this thing. Look at us go. So there's a couple of different ways that we can actually interact with setting up these queues or triggering the queues from game side. One of the things we wanted to try and do is make the queue library extremely accessible from every part of the game, and we would be able to give some of this functionality to the designers. So designers, when they're setting up their levels, can use visual scripting like node graphs, or like think of them as blueprint logic, I guess. And they would be able to fire these queues directly from that sort of stuff, that format. Timelines. So if you've got very specific animation timelines where one of the characters is kind of doing a bit of a monologue and a bit of a dance, you could trigger it directly from the timeline here, or you can just do direct calls from code. So when you hit particular code state, also fire off queue here. And this could be extended, I guess, at any point because it's kind of a universal trigger system. Yeah, so there is some manual elements to this. As much as we try and make as many things as automated as we possibly can, there are still some things that we need to input ourselves, us humans. So yeah, it's not going to write the script for you. We still need to obviously go through proper grammar checks, table reads. We still need to make sure that everybody is aligned with how the script looks, and we still need somebody to champion that script writing process. But once we've written our script and it's completely locked and it would never be touched again, right? We need a way of tracking that. So we in our case used a spreadsheet. But there are other sort of tracking softwares that you could use. But we essentially want to make sure that we can export this very easily into a CSV format, so a comma space value format, because this is the bulk importing process that the queue library will receive and be able to work with. We still need a good, as much as I joke, we still need a really good script lock process. So, as much as we are able to very quickly import things, and we will still run into your usual problems with having, a different script that the actor is having reading against versus, the one that's in the queue library. So The other manual side, I guess it's not as manual, it's kind of just like clicking a few buttons, but still manual nonetheless. We need to be able to import said CSV from the spreadsheet itself. We can do this using that bulk importing window. We can also bulk import final VO. So let's say we've gotten an external contractor to record all of our voiceover lines, top and tail them and process them properly. We can basically take that entire folder, put it into the back end, hit bulk import, and as long as the naming convention is one-to-one, the Q library is able to completely match them up. So that process is really quick, which is part of the reason we built the tool in the first place. And that means that we are able to do really quick iteration from the text to speech, the recorded VO, and any sort of line updates that we need to do. And then just an added thing here, we need to also set up manual Wwise events in the Wwise side. I'll go through that a little bit more in detail later. But essentially, we use external sources, which is a thing within Wwise, which is essentially like an audio channel, which allows us to have the VO files somewhere routing completely through the Wwise ecosystem. So you're able, once it's in Wwise, you're able to then do your standard mixing attenuations and things of that nature. That's you.
So we've talked about sort of what the human side is and what manual processes that are always sort of going to be there. But we want to actually make things faster, right? Because we don't want to spend all of this time developing a tool like this to suddenly just it all be manual anyway. So let's talk a little bit about how we can make things a bit faster. So the first big lever that we pulled is we added some text-to-speech and lip sync generation. This is something that we designed to be just for iteration. So it means our design and narrative team, they can come in and they can import some VO, or they can import their script, and we can have some TTS and lip sync automatically generated, and it's just immediately ready for them to go, ready to go for them. So they can start playing their levels, testing them, and they are immediately getting that feedback of what their level is going to feel like. So once we've sort of got that, we can start importing all of our things into Wwise and stuff automatically as well. So because we have our VO files being generated, or even if they're being imported via that manual process, we want to make sure that's all baking automatically as well, because we don't want to have an audio designer having to manually import every single VO file independently. So we can do some audio baking. So Wwise specifically has some nice features around this called external audio sources. So we took advantage of that, and that allows us to dump all of our VO files into a single file, and we can send off some commands to Wwise and go, hey, these are all ready to go, and they'll all just bake down into a nice WEM format, which Wwise understands. And that allows us to just call those and play them whenever. But we need something to call them, which is where our ID system comes in. So we actually broke everything down into two different ID systems. So we have our database ID, and this is what everything under the hood is using, and we have our human ID. So we initially had these combined, but we kept finding situations where our designer wanted to come along and go, hey, actually I want this VO line to play on a different character, or I want this in a different level. And all of a sudden our IDs changed and the gameplay implementation's broken, and oh no, we have to redo everything, and we don't want that to happen. So we sort of split that down the middle, and we created a database ID. This is a sort of a semi-hidden ID, which we use for all our VO, lip sync, localization, and we kind of use every bit that's actually implemented to use this ID. And our human ID, we can just leave for things like importing. So we can have our VO file named this human ID, and it means our bulk importers and stuff can map these to our correct points in our database. So they're called via this database ID. So with this ID separation, that's a pointer, we can do lots of cool things because once everything's represented by a single ID, we know where they are. So we can save our VO files based on that ID. So as long as we have, say, a root directory where we know all of our files are, we can name those files that ID. So rather than storing complicated file paths and everything into our game, we can just go, hey, this is your ID. We know where the file should be. Let's just look up that file, and we don't have to store that information. So to make that nicer, we separated our entire game into editor and runside, because there's really not a lot of data that we needed to have at runtime. We don't need all this bloat in our game, but we wanted to make sure that we're improving the quality of life of our designers. So we're importing things like line numbers, locations, characters, and everything into our engine so that when our designers are working, they can go, oh, I know exactly where this should be implemented. I know the context of this, and then they can work a bit faster and improve their iteration times. So when they import things into the editor, we're storing everything we need, and it's going to automatically bake that down to our runtime data, which really all we needed was our ID and character, and we can construct all of our other information from that using those two IDs we mentioned. So that's sort of the base of how we've managed to improve our iteration time, just getting the information to the designers, making sure it's all readily available for them in the editor. But how do we keep all of this information in sync? Because once we've imported all of our lip sync, our VO, there's kind of starting to be a lot of data to manage, and we want to make sure this is all called correctly. And there's not much point if we're having nice VO and the lip sync isn't in the right timing. So we combined everything into a central point. We looked at everything that we needed all of these things to do, and we went, okay, let's just have one nice script where we can call this from. So we called this the Q player. And this is combining our audio, subtitles, facial animation, and sometimes body animation, which we don't always need, but it's nice to have. And to make this even easier, we can start to look at what these things have in common. So realistically, all of these things can just be called with play, pause, and stop, and this really covers absolutely all of the functionality that we need throughout our game. So this nice Q player can really just be summed up in those few calls. However, we can't just call them straight away. We're running into issues, and I'm sure you might run into them as well, of, hey, let's just call everything at once. Surely it will be in sync. Not always the case. Say we're trying to call our facial animation player, and our animations need to load in from resources. That's not going to work because that load time isn't going to be immediate. So what we ended up doing is we went, hey, all of our players, are you ready to go? And then once we finally get the call back from all of these different players, then we finally give the go-ahead to go, hey, you can play now, and everything will immediately play in sync. It does mean that sometimes it'll be a slight delay, but we found this wasn't too much of an issue for VO and stuff. That does introduce another problem though. We don't know where we actually want to play things, because we're calling them in a central point. We're never telling them, hey, this is the character we want, this is the animation rig that we need you to play on. So we introduced something called a character transform. The general idea was that this was just an object that we could use to represent our characters in scene. So we would try and place this just somewhere in the character rig, and we could attach all of our nice references to it. So we can connect our animators, we can connect our event types, and rigs and everything. It's great. And we needed some way to track this. So along with our nice Q library that Zach showed us earlier, we introduced a character library. So this is just a central place where we can store all of the information for the character. This includes things like character name for showing in our subtitles, our wise hooks, our TTS voice. So that would be one of those edited data. So that when we're generating TTS, we can go, hey, we want you to use this voice, and it will use that for the correct character. And this is the little hook for wise, which I'll pass over to Zach to explain a little bit more.
Yes, great segue into the next section. So now that we have a character transform, a scene representation of where we want the sound to be playing, we can start to go a little bit more into the VO aspect of it. We talked a little bit, well, I talked a little bit at the beginning about external sources. What does that mean? That doesn't mean anything to anyone. So I guess in a standard Wwise ecosystem, we would grab our sound, we would put it into the Wwise editor, we would load it into a sound bank. On the scene side, we would need to make sure that sound bank is loaded, giving it access to play whenever it was sort of necessary. What external sources does, it kind of skips the step of putting audio into the editor and just sort of says, hey, I actually don't want you to go from Wwise, the program. I actually want you to play from over here. I want you to play from a separate database completely. And Wwise goes, yep, that's fine, no worries. Just give me a reference and I can just make sure you're streaming it in and I can play it from there. So I guess think of them in this scenario as like character funnels. So this is the entry point to the Wwise ecosystem, again, where we get all of our nice middleware functionality, like your mixing, your attenuations and things like that. It's a very brief explanation of external sources. I'm happy to go through it in detail a little bit later as well in the Q&A. And so the reason we're using them in the first place is because I mentioned at the start that when we receive our voiceover files from the actors, it's all in one big folder. We need to be able to very quickly put that in and replace those files and hit bulk import. We couldn't do that if they were individual events in Wwise. So if it's like if the first line is, "Hey Ben, how are you?" That'll be one event. And Ben goes, yep, not bad. That would be another event. And you can imagine that, with a game with, thousands of lines, that starts to add up very quickly. And that then, falls back into my domain, where I have to then maintain a lot of Wwise events. I don't want to do that. So I'm kind of like handballing that to the Q library functionality. And yeah, keeps Ben out of my Wwise session as well. Cool. Before I go any further, I know some of you are, audio fluent people, but I guess there are some specific VR audio concepts you should probably know. In VR, spatialization is incredibly important. If you imagine that, the point of view is always going to be from the person's eyeballs, so you would imagine everything needs to be exactly where it would be in real life. So the way that we achieve this is through something called head-related tracking function, or HRTF, which is some very smart person has basically created a mathematical model to describe how a person's head, body, and ear shape affects the sound waves as they travel to somebody's eardrum. The TLDR, or the basic version of that, it essentially affects the filtering of a sound based on elevation, left, right, up, down of a person's head. Each person has got their own HRTF measurement. So, the width of my ears are very different from the width of Ben's ears, which means that the way that I perceive the world, or perceive audio, will be different. Everybody's got a different HRTF value. But what we can do, or not me personally, but what the binaural processor can do, is it takes sort of an average of everybody, let's say everybody in this room, and it bakes it down to this is a standard kind of HRTF default that will work for most situations. So it takes that functionality and then it applies that filtering at runtime, which is awesome. So it essentially, in our situation here, it will filter a sound over here using that HRTF mathematical model. It will apply that at runtime, and it will apply a certain amount of filtering to there versus above my head versus below me. Fascinating stuff. Again, I can talk about this kind of stuff all day, but I will move on. This is really important because obviously it needs to be applied to the voiceover as well. So my character needs to be very specific, and it needs to be coming from their mouth. But we ran into a problem very quickly. The way that you would usually put a sound into a VR game is you would grab an event, you would put it on an object, you would hit play, Bob's your uncle, great, the sound's coming from that object now. But with the Q library functionality and with the way that the shadowed design, I guess, the scene hierarchy was set up was that we could have lots and lots of inactive or active character transforms of the same character, and that could be, due to, some inactive timelines, or, that the player hasn't yet unlocked that particular thing. Anyway, we can have up to 6 of the same, Doctor character transform. So how do we choose? How do we choose which one to use? Excuse me. Excuse me. The solution, well, we already have a solution. It was, this stuff is being calculated at runtime. So before it fires off each and every queue in the queue player, it would determine which character is of the highest priority, is the closest proximity, whether or not it's active in the scene, and it would do an evaluation of that and then say, yep, no worries, this one here is the one that I should be playing from. And then it locks all of that data, including animation, including VO, including subtitles, to that character transform, and that would be my point in the scene that it could attach to. And then we get the voiceover coming from the character that we needed in the scene. Excellent. So that's kind of all of our key pillars. We've answered all of these questions. So let's see what that looks like in practice.
Let us continue with the next session. You made a friend here at Greyvale, a benefactor turned patient. Do you know of whom I speak?
Martha Hancock.
Oh, Jessica, you look dreadful. Ooh, looks like that last session really knocked you around. Oh, poor thing. You take it easy now. Tell me, what's the latest with your billionaire nemesis?
You mean Parker Wakefield?
Of course.
So that was a short clip, but we've just discussed there are a few things going on there. So we've managed to have playback and control of narrative cues. We've got text-to-speech and lip-sync generation running. We've got in-sync voiceovers and everything. That's all coming from a bulk CSV importing with our narrative scripts. We've got automatic character creation and management, subtitles and localization. Our Wwise is all hooked up and the audio department's happy. And hopefully, at least I think so, it's a nice, easy-to-use interface. But what is it really in the end? It's kind of just a big database. So if you're going to take anything away from this, I would recommend just trying to group all of the information that's relative to each other together and just making sure it's in one place. Having just that centralized location where you can just go, hey, let's call this one thing, and it's going to play everything that's related to that has just been a massive time saver for all of our projects. Yeah. Thank you so much, everyone. A lot of people went into making this game, and it's been really cool and to organize this talk. Oh. Any questions?
Just a quick little fun thing as well. The person who plays the old lady there, Martha, is actually Misty Lee. She was the inventor of the clicker sound from The Last of Us. So yeah, very cool to be working with some amazing actors.
Could probably have just shouted it. Can you see yourself using this tool for future projects at PlaySide?
Yeah, absolutely. We actually have this on some in-production projects, which is really good. Yeah.
My question is, with the character prioritizing, Do you have single numbers assigned to each individual character, or does it rotate on cue?
Yeah, good question. So it really depends on the context. There will be an element of manual like inputting that will need to happen. So if it's a really, I guess, narrative critical moment, then you'll put that as the highest priority. But sometimes that one won't be active. So there is a little bit of manual input involved in the prioritization for sure.
Thanks for building the tool. It's saved us a few times. Talking about the massively important, trying to do it quickly, script lock, what happens when the team need to pivot quite significantly? Is there a different sort of format that you guys want to explore? Or are you sort of thinking that the whole system with the Excel spreadsheet is sufficient?
Is essentially what you're asking, how would we improve this tool in future? Yeah.
Well, what's in your mind about what you want to improve on?
I mean, I've already thought about this answer, and you might have a different answer. But I would love to make it a completely separate interface, like completely outside of the game engine completely. So whether that's a web thing or whether it's it's its own sort of format, but similar to the way that some of these third-party tools that I mentioned earlier have done it. It'd be great if you could just like write the script directly into an external tool, and the narrative writers don't have to like download Unity or Unreal, whatever it is. Like they can just write whatever they need to, hit ready to go to game essentially, as a completely separate tool. That's what I would do.
Yeah, I think that's generally the right answer. We looked into doing that very early in the process, and at the time it was just not something that was viable. But being able to just almost throw out our importing process completely and having that be an automated process for our team would be really awesome.
Would you like to touch a little more on how you sort of integrated the lip sync facial animation stuff into this system when you need to like generate that in bulk and stuff?
So it kind of depends on the project. So I guess an easier example is a project that we have in production where we can essentially just take the VO files, and there are many processes online now that will just take that file and go, hey, this is the shape that the face should be in right now, or this is the rig position, and it can kind of just take it from there. And that can just be a typical text file, which you can just throw in a location, and then however your animation setup or pipeline is hooked up, you can go, hey, read that file. This is what the facial animation should look like. Does that kind of answer the question?
Yeah, I think so. So just like you're using third-party tools for that generation, and then you're just including it in your database.
Yeah, essentially. Yeah.
Cool.
I might be able to add something here as well. In Shattered here, we actually used some like automatic lip sync generation as like primer, or as kind of like a demonstration of what it would look like. But actually, we got some of the actors, or the acting agencies rather, to also do some facial capture recordings as well, while they also recorded the lines. So we were able to already have it in sync. We had like it was on like an iPhone. They did the whole dots on the face, and we got that recording as like a raw asset that the animation team could clean up. So you can and then that was then added into the animation slot within the Q library. Yeah.
Cool. Thank you.
You touched on it quickly, I think, but in terms of a conversation, and you've got multiple lines of dialogue to form a conversation, are you doing that with like the node builder in terms of linking them together that you mentioned before, or? Yeah.
Again, it probably depends on the context as well. A lot of it was the node builder, excuse me. But some of it was also like pre-scripted, timelines, and we would just kind of hit play on the timeline, and it would play a conversation where it was, accompanied with like, body animations and things like that. So yeah, it really depends on the context. Yeah.
And just for like, do you guys handle like branching dialogues, and would your narrative team do that in the script, or is that you do it in the node stuff as well?
Luckily enough, it was not something that we necessarily had to handle. But since the system's kind of just handling each sentence individually, it would be easy enough to just be like, oh, in this specific situation, you would call this line instead of this line. Let's go off on this dialogue branch. Thank you so much.
Thank you. Appreciate it.